É isso aí, pessoal. Boa tarde para vocês. Estou aqui, Cristiano Linuxman, na área, né? Eu fui incumbido aqui do Papo Precisa de Mim de ajudar nesta live, então, sem mais delonga, vou trazer aqui a pessoa que pediu a ajuda do Papo Precisa de Mim. Então, se você tem aí, quer fazer um conteúdo bacana, pode trazer o Papo Precisa de Mim aí que a gente ajuda. Agradecer aí o pessoal da rede também, né? Que tem nos ajudado, tem me ajudado. Vamos trazer aqui nosso querido amigo Edgar. Boa tarde.
Boa tarde.
Tudo bom, senhor Edgar? Conte para nós sobre a live de hoje, que é StreamPipes.
Muito bom. Bom, primeiro de tudo, obrigado, Cris, pela ajuda e pelas risadas. Foi bem legal fazer esse evento. Então, eu recomendo, quem quiser aí, além de uma grande organização e ainda dar boas risadas, é bem legal. Me deixa, eu posso compartilhar minha tela aqui já, né?
Pode.
Beleza, então deixa eu aqui compartilhar, ok, share screen. Aqui, share. Tá vendo minha telinha
aqui,
agora?
ó. Vamos mandar aqui um boa tarde para o Davi, um boa tarde para o Raí, boa tarde para o Fred, o nosso responsável por levar essa live para 3 fronteiras, né?
Olá, Fred, te agradeço, graças.
Esse aqui eu não consigo ler.
Ah, deve ser um nome bem legal.
Será que a gente já começou uma live com bots?
Com bots?
Você sabe que tem os bots, né?
É uma boa, hein? Eu, por hora, não tenho nenhum bot aqui, mas pode ser que tenha. Pode ser que tenha, sim.
Já temos 9 pessoas online aí. Não deixe de deixar o seu like aí. Cadê aqui? Vai, Edgar, é com você agora.
Show! Então, pessoal, primeiro de tudo, muito obrigado por vocês aí reservarem essa hora do dia para a gente falar de um assunto super interessante. Então, vai estar aqui com a gente hoje os criadores do projeto Apache StreamPipes, certo? Então, a gente vai estar com o Patrick, com o Philip, certo? Que vão estar aqui, que já estão aqui online, aqui no backstage com a gente. E eu estou aqui também, junto com o Cristiano, para poder facilitar essa live, esse webinar com vocês, tá ok? A ideia aqui é fazer tudo da forma sempre bem descontraída, da forma que sempre o Cristiano vem trazendo aí muito conteúdo aí para a nossa comunidade aqui no Brasil. E a ideia é deixar aqui todo o conhecimento com os próprios criadores do produto. Bom, então assim, para a gente poder fazer um guarda-chuva geral do que a gente vai falar, a gente vai focar muito na questão de indústria 4.0, né? Então, ou seja, esse aqui é um termo que já tem um bom tempo no mercado, mas eu diria que a gente nunca sentiu tanto a falta de já ter implementado alguns conceitos que são trazidos por indústria 4.0, como, por exemplo, todo o processamento de IoT, todo o processamento de streaming, todo o processamento de arquiteturas reativas e preparadas para que a gente processe um processamento de dados massivo e ter realmente todo o monitoramento em tempo real do que acontece em diversas indústrias, teria nos ajudado bastante em alguns cenários, né, que a gente viu, né, esse ano, né, todo mundo torcendo para que esse ano acabe logo, porque esse ano a gente teve aí uma surpresa muito desagradável para todo mundo, né, infelizmente aí nós perdemos inúmeras pessoas, né, devido a toda essa questão da pandemia, e a pandemia também nos trouxe desafios que mostrou o quanto várias indústrias não estão preparadas para reagirem às demandas e os problemas que existem assolando toda a humanidade. E quando eu falo isso, eu falo assim, realmente em âmbito global, não falo somente de Brasil, né? Então, a grande questão é assim, como que a gente responde, né, a todas essas demandas de inovação que a gente pode enxergar hoje em dia e os desafios que são totalmente novos, né? Então, a gente tem aí a questão de manufatura. Eu não sei quantos de vocês já perceberam, mas, por exemplo, alguns produtos que a gente já está buscando no mercado estão em falta. E muitas das vezes a explicação, pelo menos que a gente escuta, é a questão da matéria-prima, é a questão que, de repente, esse produto não ficou pronto e assim por diante, né? Saúde, então, a gente pode ter aí inúmeros casos, né? Ao longo da pandemia, as pessoas, toda a indústria de saúde, ela foi aprendendo como lidar com a pandemia. Então, seja, eventos que, de repente, não foram monitorados no início da pandemia, hoje em dia eles são fundamentais para que realmente a indústria saiba reagir, especialmente num cenário onde a gente está buscando vacinas e tudo mais. Eu posso falar, eu tive Covid-19, graças a Deus, eu e várias pessoas da minha família e próximas da gente, graças a Deus a gente não sofreu, né, as mazelas que muitas outras pessoas sofreram. Até acredito eu que o time disso, como faz muito tempo, acredito que a indústria estava muito mais preparada para isso. Então, esses insights, toda essa informação que a gente teve, ela tem que ser usada de forma benéfica para todo mundo. E, por último, a questão de varejo e logística, eu coloquei aqui 3 indústrias, só para a gente poder ter alguns insights, algo que vai mudar drasticamente, né? Então, se você vê aí, por exemplo, as empresas de entrega de comida, de supermercado, foram empresas que cresceram absurdamente, né, durante esses períodos de pandemia, de lockdown e tudo mais, porém, a gente também se deparou com um monte de problemas que eles não tinham o preparo para poder responder. E, né, por último, né, assim, a mensagem que como escalena, né, o porquê que a gente, como que a gente encontrou e, assim, se apaixonou pelo StreamPipes, é que, assim, né, isso aqui é algo que a gente está conversando internamente, não há espaço, né, para um mundo que não esteja conectado, integrado e reativo. Quando eu falo reativo, é que o mundo ele vai começar a disparar eventos de sensores, de máquinas, de pessoas, de locomoção, e esses eventos conectados, correlacionados, vão nos dar insights que a gente, até o momento, nunca foi capaz de perceber. Então, o StreamPipes é uma tecnologia fantástica que visa democratizar que ainda ficam presos na mão de poucos, ou conhecimento de poucas empresas, e o StreamPipes é um projeto 100% open source, que faz parte, é um projeto incubado dentro da Fundação Apache. Então, agora eu vou passar a palavra aqui para os fundadores do StreamPipes poder mostrar para a gente o que a plataforma é capaz de fazer. Agora eu vou mudar aqui para inglês um pouco. O meu alemão não é essas Coca-Cola. Então, vamos lá. Patrick, you there?
Yes, I'm here. Hi.
Okay. So, guys, I gave my quick introduction and context. So, the show is with you guys, okay?
Alrighty. So, can you just... yeah, you see my screen, perfect.
Yeah.
So, hello everyone to this webinar here together with Scalena. So this talk is about Apache StreamPipes and industrial IoT from zero to hero in a few clicks. This is going to be a joint talk together with Philip, who's going to take over the demo part later on. So just a little quick introduction about ourselves. Typically, you see here on the right side the 3 of us. So it's in the middle, me on the right, and normally Dominic, who's not here with us today, at last year's ApacheCon 2019. That's basically where we submitted a talk with StreamPipes, which was open source up until that point, but not in the Apache Software Foundation. So last year in November, we then joined the Apache Incubator as an incubating project, and we're PPMC members of Apache StreamPipes. And if you want to tweet about us, you find the Twitter handle here with @StreamPipes. As said, we're not only working in open source, we're open source enthusiasts by night, but by daytime we are researchers in Germany at a research institution called FZI. And here we basically focus around the topics of stream processing, distributed systems, as well as industrial or general IoT topics. Coming to the agenda of today. So first, I'm going to give a brief introduction into the landscape of industrial IoT within topics of a factory 4.0. Then we're going to dive into the StreamPipes 101, just to give you brief introduction on the slides, what it is, and then switch over to the interactive or more interactive demo part, where we're going to show some of the features of StreamPipes, which is done by Philip. Then I'm going to continue and showing how you can extend StreamPipes, because this is a really fundamental building block of our technology, that you can flexibly extend it to suit your cases at various different kind of situations. And then I want to show you our roadmap that we follow in the open source community and how you could potentially contribute to the project.
Patrick, let me just call Philip, just because both of you are gonna be with gonna be presenting.
Yeah, sure.
Camera. So Philip, you'll be there, okay? I'll be here in the backstage. Okay.
Yes, I'm also here, and also welcome and thanks for having us.
You guys are welcome.
All right, so let's dive in. So what we see here is more or less a typical scenario within the domain of manufacturing. And here we see typical, more or less partly automated use case, where we got maybe some automated robots that do some pick and place operations. Here on the left side, we can see maybe some filters being placed on a conveyor belt. Then we got some machines that are inspecting the filters, doing some assembly task or welding task. And lastly, there's also a robot that is doing the packaging for the delivery lastly. And when we look at these various stages along this production line, we see that there are IoT streams and data streams everywhere. So if we look at the robots, we got some maybe gripping force from the pick and place operation. We got camera images from the visual inspection. We got machine data that is coming out of machines, and we got also PLC data, which we can harness then later on. And to complement that, we also might see situations where we also have environmental data, such as installed sensors that measure temperature or humidity within a certain manufacturing environment. And collecting these various data sources is not so easy, especially because nowadays we're not starting on a green field. So we're often speaking or are confronted with a so-called brownfield deployment, where we get old machines that might have really old protocols. We might have situations where we get the mix with new machines with more modern or standard protocols. And so this is really a challenging task, just to bridge that first gap in order to get that data out of the collect this data out of these various sensors that are available, and integrate them first of all into a centralized environment. However, luckily there are other related projects such as PLC4X, a main of IoT projects within the Apache Software Foundation, that build a great universal protocol like a JDBC abstraction to various databases for specific protocols here, main of manufacturing, such as PLC data or Modbus. And StreamPipes is then used to sit on top, connecting to these kind of standard protocols, but also leveraging the more universal protocols such as PLC4X, or providing specific extensions to it to connect to other, let's say, more old fashioned protocols, in order to first load and connect the data from the various sources, and then do stream processing really easily. And what I mean by easily, that brings us to the second part about StreamPipes 101. So we see StreamPipes as this kind of IoT toolbox that is really targeted towards the non-technical persons, like the persons that don't have that like deep IT skills, that don't or cannot program, and we want to enable them to easily connect, analyze, and exploit these data streams once they're connected. And by toolbox, I mean that StreamPipes itself consists of various different components. So first of all, there's StreamPipes Connect, which is an adapter marketplace to connect various sensor data into the system. Then the central component, the pipeline editor, is then used to use reusable algorithms in order to analyze that data. Then we got an internal dashboard where we can live monitor the analyzed all raw data. As part of our last release that we just released a couple of weeks ago, we published a beta version of a data explorer, because for some situations it might not be sufficient to only look at live data, also want to store historic data and browse through it just to see maybe like the last half hour or the last day, what was really going on in my system and with the data itself. And lastly, we also provide means to trigger internal notifications. So how does it work? Just really on a high level, we get these 4 steps. So as step 1, we connect to IoT sources. That's where I already mentioned we got StreamPipes Connect with over 30 adapters that leverage existing unified protocols or adapters such as PLC4X, but also can connect to other standard protocols such as ROS, which is more common in the robotic domain, but also to Kafka, to REST interfaces, or also provide means for debugging, for example, to replay CSV files as well. Then as a step 2, once the data is into the system, you can leverage around 100 different so-called pipeline elements that can be deployed standalone or distributed. And these pipeline elements are data processors or sinks. So these can range from simple filters that are applied on the incoming event stream to more advanced or even advanced algorithms or even machine learning models that are wrapped as a pipeline element. Then we can deploy and execute basically in any way. So we build on top or we package our application as various microservices within Docker images. And therefore we can run on various types of infrastructures ranging from x86 over ARM to any other kind of infrastructure. And we also support Kubernetes deployment via Helm charts. So and lastly, the more interesting part is lastly realizing use cases. So what we see StreamPipes really being used for are cases where you want to continuously monitor your assets in your manufacturing or in any other domains. You want to maybe calculate some statistics or KPIs, or where we really want to go more into that kind of AI world as well, as you can also wrap your machine learning models and apply that on not only sensor data, but also on image data as well. So here on a more colorful picture, so the typical use cases are then that we provide, for example, for the continuous asset monitoring, a way to let you define the dashboard you like and to provide live insights about the current state. You can calculate live KPIs on that are relevant for example, managing your production line. And then coming more to the advanced analytics side, you can use StreamPipes in the beginning of a project, for example, to easily collect training data, because we get rich adapter marketplace to connect to various assets in your, for example, production line or any other data sources. You can easily use it within a couple of minutes to build up this kind of training data collection pipeline, just to get the raw data out of the system and use that later on to train a machine learning model, for example, for, in that case, process or product quality inspection, that you can then deploy as a pipeline model element inside StreamPipes as well. So as said, we're targeted towards the non-technical folks here. So therefore, we see ourselves as this kind of no-code self-service toolbox that offers a really high level of abstraction to model these kind of analytics tasks. And as said earlier, a central part of StreamPipes is the so-called pipeline editor that you see here on the right. And so once data is connected into the system, it's available as so-called data streams. And a data stream is basically a sequence of events that is provided by an instantiated adapter. So for example, if you connect to PLC in your production line or to an industrial event source, such as a robot, for example, you then make this data stream available to the system, and you can leverage here to build your analytics pipeline. So this is the first step, and you can interact with it by dragging and dropping the data stream into the canvas. But Philip's going to give you a more detailed introduction to that in a minute. Next, once these data streams are into the canvas, you can switch over to the data processors. And the data processor then applies a configurable function to one or more input event streams. So this can be really easy ones, such as stateless algorithms. For example, a filter. This filters for a given threshold. So for example, if you're not interested in events that are above, let's say, a numeric value of 10, I just can apply that rule here. And it produces, again, an output stream that is then lastly consumed by a data sink. And data sink, we differentiate between internal sinks. So these are the ones that are provided within the toolbox. It can be a dashboard for the live visualization or the data lake to collect the training data, for example. But we also provide a rich set for third-party sinks. So you can publish these results back to Kafka, to ROS, to a REST endpoint, and you name it. So this, all in all, so data streams, processors, and sync form this kind of pipeline graph here that you can then start and deploy in your system.
Patrick?
Yeah.
Can I just raise a few questions from the chat already, just to get a chance to?
Yeah, we can do one or two, sure.
Okay. Just one for a while. A friend of ours, Leandro Tedescos, is asking that the logic is where's the logic is running. That's not that clear yet. There is an engine to running this logic, or like let's say a StreamPipes engine, or you are using the kind of external libraries to execute any logic when you're processing the data. I believe that's the really good translation.
That's a really good question. I think we're going to come to that, how it's really done under the hood later on. But just to give you a short answer to that, we provide several wrappers for different kinds of runtime environments. So we provide runtime environments for a standalone deployment as a so-called processing microservice. This is in Java. We're currently working on porting that to Python as well to address more the data science folks here, because they're more familiar with Python. But we also provide wrappers for deployments in big data stream processing frameworks such as Apache Flink or Apache Spark. And we have some prototypical implementations for Kafka Streams as well. But this is, I would say, not the richest, or not the one that is developed the furthest, let's say. But we're gonna go like how it's done with the logic later on. The key takeaway here in the 101 is basically entering like the demo in a couple of seconds, is that the end user, like the one that is not really familiar with writing Java code or Python code, is completely abstracted away from actually writing any lines of code. So it's only configuring processing services that are then later on executed in these kind of runtimes. But as said, we're gonna come to that later.
Okay. I think that's clear now. Cristiano, I saw another. Eu vi outra pergunta aqui, mas acho que vamos deixar um pouco mais para o final, que aí acho que o Philip vai mostrar algumas coisas que podem responder um pouco a pergunta que foi feita aqui na sequência, ok? Ok.
Okay, Edgar's gone.
Let's go. Go.
Okay.
I think you can
Okay, I
continue.
continue. All right. So as said, we're not only using a pipeline editor as part of the toolbox, but there are also various other parts. Just to highlight them quickly here. So we got StreamPipes Connect, as already mentioned, like the rich adapter marketplace. And you see on the right the dashboard or data explorer for visualizing live data or historic data, and also the notifications. So here you get a more high-level overview of the architecture itself of StreamPipes. Still not on a technical level, but we can discuss that later. So my point here is that StreamPipes is just more than a web app. So behind it, there are various algorithms deployed or agents running in different kinds of microservices. That is, for example, managed by the pipeline management as part of the core. And then like level more towards the data source, we got various pipeline element microservice containers. So we're using asset Docker for the packaging and deployment part. So there we have various algorithms such as the trend detection or classifiers running as so-called pipeline elements. Then like the transport layer between pipeline elements is realized by using message brokers that can suit your use case. So we got implementations for using MQTT for a more lightweight abstraction in communication between different microservices, but also can scale to use Kafka here as well. And then we got more or less sitting closely to the data source, containers or microservices for the connect adapters that are then deployed right where the data is generated. So coming to the demo part, first I want to give a brief introduction of what we're seeing just to make it clear. So the first demo is going to be about analyzing PLC signals using PLC4X and StreamPipes. So what we want to show here is how easy it is to access industrial data sources, such as PLC data. We want to show the pipeline editor and how we can use it to, within a couple of clicks, calculate some KPIs. We want to then visualize that that results in a live dashboard. And exactly. So we also got so-called plugin system or apps. We're not going to go into details about that one, but what we can also do is, make, for example, photos of a machine and then project the live calculations of these KPIs onto that photo and look at it in the dashboard as well. And as part of the second demo, we want to switch over more to the AI-based usage of StreamPipes. So here we see a product classification use case. So we got filters that are coming in a tray, and we want to count that filters and draw bounding boxes around that detected filters. So here we connect to industrial cameras such as Smobotics or Basler that provide us with the raw imagery. And as already said earlier, we provide support for various data modalities ranging not only from sensor data, but also from image to audio data as well. And here we want to showcase how easy it is once you get your AI model, how easy it is to apply it on an incoming data stream in order to detect, lastly, the filters and count them. So with that, I'd like to switch over or hand over to Philip, who's going to run the demo.
So thanks for the introduction, Patrick. I just started to share my screen. Can you see it? Okay, perfect. So for the demo, we set up a StreamPipes instance running on a small server, and it is located in our offices, and also we have a physical PLC connected to this computer. So first of all, you have to log into the system. And in the login page, you get some information about how many pipelines are running, what kind of pipeline elements are installed. And if we switch to the pipeline editor, you can see that we have already integrated several data streams. For example, here we have machine data, which is connected, where you can see the description, but you can also directly see the live data, which is coming into the system. And as Patrick explained before, we have an algorithm toolbox with many different algorithms. For example, simple filter algorithms or also classifications, but it can also be like time pattern detections and also more advanced algorithms like machine learning models, which I will show in the second demo. In the end of a pipeline, you usually have a data sink, and there you can add, for example, a data lake or a live dashboard, but you can also send the data to third-party systems like over MQTT or MySQL. Or, for example, if you model a rule that, for example, threshold value is too high, you can also use an internal notification to notify a service technician on the field. In our first demo, I will switch to our demo factory. Here we have a machine which is sorting those pallets with boxes on it. So here we have multiple sensors in this setup that measure the height of the box. And this is like a typical use case. You have an older machine which is working, but you don't have much more information for this machine. So you don't know how many packages it sorted. You don't know if there's any problem. If we look here at the PLC, so we have a physical PLC which is reachable under this IP address. And here you can see that you have multiple registers that you can read out. And now the first step typically in such projects is we have to connect to those machines or to those data sources. And therefore, we've developed StreamPipes Connect. And here we have an overview over multiple adapters which are integrated in the system. So for example, we have an adapter for Kafka, also for REST APIs. For development purposes, you can also upload CSV files or XML files. And we also can connect to databases or OPC-UA or multiple protocols. You can also write new adapters with our software development toolkit to support specific machines that you want to integrate at a later point in time. To connect PLCs, we are relying on the Apache PLC4X library. And to do that, we have to select the adapter and provide the IP address. This is the one which I showed you before from our PLC. Next, we have to define a polling interval, so how often we want to collect the data from the device. And then we need to enter the information, what kind of registers we want to read. So we can enter those manually by looking them up and entering them here, but we can also export a CSV or XML or Excel file from the TIA portal, which is usually used to program such Siemens PLCs. And I already uploaded it here into StreamPipes, and it contains all the names of the registers that we want to read. If I click on Next, we can see how the event might look like later. So here we have the event structure with the individual values that we have. For example, here we have the sensor value of the entry of the conveyor, and we can also configure this further and add more information. So here we see it's a Boolean value. For numerical values, we can also transform the data directly on ingesting into the system. We can also delete or add new properties here or new values. For example, we want to append the current timestamp. So on data ingestion, we will add the current timestamp to know when this event was triggered. In the next step, we give it a name, for example, PLC, and start the adapter. And that's how you typically connect to multiple data sources. So the process is the same either when you're using a SQL server or, for example, an MQTT broker as well. And now here you get an overview of the live data with all the Boolean values. And the common use case is that we use this low-level Boolean values and calculate some simple KPIs based on that. Therefore, we are switching back to our pipeline editor. Here you can see now the new data stream, which we just created. And via drag and drop into our pipeline assembly, you can start modeling the pipeline. If I switch to our data processors, you can see the different ones that we are supporting. And the first KPI that we want to build is how many big boxes were sorted by the machine. Therefore, we have the Boolean counter. Also via drag and drop, we add it to the pipeline assembly and connect it. And now a configuration dialog is popping up where we can select the sensor from our data stream. So we want to have a look at the high sensor, so when a high package is detected. And we want to increase our counter when the value changes from false to true, and save it. And now we could, for example, store this counter in a database or apply a rule on it. And for the demonstration, we just want to put it on our live dashboard. Therefore, we use the dashboard component and give it a name. Next, we also want to calculate how long the packages are on the conveyor. So if this time gets too long, there might be a problem on the machine. So we switch back to our data processors, and you can also search for different processors. And here we want to measure the time between two Boolean sensors. So I use this component and connect it. And we want to start the timer when the package is at the left entry. And we want to end it when it's at the left exit. So we know how long it is on the conveyor belt. And the result should be calculated in seconds. And we also want to print this value on our live dashboard. I call it timer, and I save it. Now we are done with modeling the pipeline, and we can execute it. Therefore, we store it and give it a name. Call it PLC counter, and we are executing it. And now the individual components are deployed in the backend. And because the question came before, if you click on Show Details, you can also see the endpoints where the algorithm is now running. So we rely on a message broker, which is responsible for routing the events. And the individual algorithms can run on also distributed computers. And we also, as Patrick mentioned, have different wrappers, for example, Java or also Flink. So the system abstracts this technical information from the user and does this automatically in the background according to the setup which the administrator set up the system. If I click now to the live dashboard, you can add multiple dashboards here. And I already prepared one with some example charts. So here you can see a temperature or flow rate value from other data sources. And we can add our new KPIs. So I add a new visualization by selecting the counter. And we want to present a single value. So just present the counter value and create it. And additionally, I will also create a value for the timer. So also single value. And I select the time field. Measure time and create it. And now we can store it. And if I switch back here to our sorting machine, now you see it's a small package. And now if the big package enters our sensor, the counter gets increased. So we can use this to quickly retrofit an old machine, connect to data, and also create those KPIs. The data is not only available in a live dashboard, you can also, for example, persist it and export it later for some data science tasks, for example. So therefore, we have the newly developed Data Explorer, where you can also look back in time. So a user can decide whether they want to just put the data on the live dashboard, so the data is not persisted, or if they want to store the data in the data lake. We do not only support sensor-based data, we're also supporting images. So usually we show it with a live camera, but because of the current situation, I'm relying on a recording. So here we have a sensor, which a camera, And we see we have those images from those boxes containing those filters in here. And now we want to detect those filters with a pre-trained machine learning model and count them, and also visualize them on the dashboard. So the modeling is the same. We select our filter data source and connect it with an object detection, which we have trained before. So here I select the object detection, and I connect it. And now we have to configure it. So we want to detect objects on the image. And here we have already prepared multiple machine learning models, and you can also add new models during runtime if you trained it on different data. Here we have a pre-trained model, which is detecting filters. Now what we have is we get our image stream into this component. This component applies the machine learning algorithm and appends the bounding boxes to the event. So now we have the location and the amount of filters in our image. To show this in a demonstration, we want to enrich our image. So here we take the image and the bounding boxes as an input and put an overlay into the image so that we can see where the model detected the individual filters. Then we save it. And in the last step, we also visualize it on our live dashboard. Select it here and give it a name. And now we can also run this pipeline. And execute it. Now the individual algorithms are executed again in the backend. And if we switch to our live dashboard, we now can add a new visualization with the just created pipeline. So here we have the filter detection. We want to visualize an image this time. And we can give it a name. Create it. And now if I put it up here and save it, you can see that we have the results. So here are the filters and the detected the images with the detected filters. And now we could, for example, also apply a rule that in each box 5 filters should be placed. And if not, we want to notify a service technician or somebody on the shop floor. So the system is quite configurable. So everything you saw can be installed during runtime. So we have those multiple microservices, which Patrick will explain in more detail now. And those, once they started, they register at the backend, and the user can install and uninstall individual algorithms. So you can configure the toolbox specifically for your use cases and also just use those algorithms which you need. So that was the demo. Do we have questions to the software, or should Patrick continue? He will give you some more feedback, more detailed information about the technical details.
All right. So thank you very much, Philip. I switch over to my screen here. Yeah. So now that we saw like the rich toolbox of StreamPipes, let's dig a little bit deeper under the hood, and I want to show you how you can extend StreamPipes to suit your use case and to write your own data processor, for example. So as previously mentioned, we provide various runtime options for the so-called pipeline element microservices. And we differentiate between standalone components and distributed ones. So what we saw here in the demo itself, those were standalone components that can be written mainly in Java or using complex event processing libraries such as City. And as already said, we're currently working in the community on bringing out a new Python wrapper for StreamPipes, so you can also write your application log in Python. On the other side, we got distributed runtime options. Here, you can write your application logic, for example, in Flink, which we then use. So we had a demo about how we use our distributed wrapper for Flink at the Flink Forward last year. So it's on YouTube, you can check it out for more details, but in general, what we use here is the remote execution option by Flink. So we then upload the Flink jar of the job to the Flink cluster, and we handle all the the input messaging and outgoing messages as well. So how can you then write your own data processor? So therefore, we provide a software development kit and Maven archetypes to easily come up with an initial project skeleton for writing your own data processor. So let me just walk you through a quick demo here. Let's say we got a MyCreator data processor, which would be like in Hello World in StreamPipes. What this data processor is doing is it has no input requirements on the incoming data stream, and it should only append a user configured greeting message. So in that case, it's Hola Brasil. So hopefully I pronounce it more or less the right way. And what you see here on the outgoing side is that every incoming event gets this message appended to its already incoming event. And therefore, a data processor itself, like the microservice, we provide an API to register and communicate with the backend, and the user itself only, or the developer of that creator processor only describes the description, which I'm going to show you in a couple of seconds, and the actual application logic. And we're going to handle like the invocation and the runtime deployment, and like to what topic to subscribe and to what topic to publish completely from the actual implementation task. So what we see here in the top part is the description layer, which are more or less or follows a build-up pattern to define the model of that data processor. And what I mean by model is that we differentiate between the transport layer task. So what kind of data formats are supported here? For example, a JSON format. What kind of protocols we support? Here it's Kafka. We also support MQTT, so we can easily say, okay, that this data processor should support MQTT as well. We can then define stream requirements. So what we saw, for example, in the demo with the image data from Philip, with the product classification, we can only apply object detection on an input stream that contains an image. So here we can define certain requirements, what kind of semantic values should be within the incoming stream. So here, for a dummy processor, we don't have any requirements, therefore it's any property. We can then define parameters that are rendered as so-called static properties as part of the StreamPipes UI. So here, a really basic one, it's a text parameter that generates this, this textual input then in the UI, where a user can then enter the greeting message here, Hola Brasil. And we also describe what is done by the application logic here, the creator itself, like how the output event looks like. Here, we only append the greeting message to the input event, but we can also say we want to provide a custom output, or we can let the user select what fields to forward, for example, then using another strategy. Then on the application logic side, we provide an interface that you can implement, and it consists of 3 methods. It's the onInvocation, which is called in order to extract the parameters provided by the user. But you can also establish, for example, database connections here on the invocation side. So once the pipeline is started, then we got the onEvent method, which contains the application logic. Here you are provided with an input event and an output collector, and you can access various fields in the input event. Here, for the sake of simplicity, we only append like the greeting message with greeting key to the actual event and forward it to the output collector. And then there's the onDetach method that you need to implement, for example, to clean up your database connections once the pipeline is stopped again by the user, or to clean up any other connections that you made in the on invocation. This dummy project can be found in my private repository on GitHub, or it's not private, it's publicly available, but on my own repository on GitHub from the ApacheCon this year. So if you want to check it out, it provides detailed description on how to run it and how to walk, how to get going with the StreamPipes itself and the Creator processor. So coming to the roadmap, as said previously, we're currently working on the Python runtime wrapper, just to improve the SDK and the development of pipeline elements to target more the data science audience here. We got several requests that it's super interesting for them to also provide their kind of data processors as they're still developing more the Python side of things. They want to use Python SDK to wrap their application logic. Then we got an experimental branch steering towards more the edge deployment side of things. So we can then assign individual Python elements that are wrapped as these microservices in Docker containers to individual nodes. So here we're working on having this kind of node controller that is then responsible for locally or remotely managing the pipeline element runtimes. Then for some, it's not only efficient to use the graphical editor to model the stream processing pipeline. So here with the StreamPipes client, the idea is to define and create pipelines from code, which are then automatically deployed in StreamPipes. We're working on pipelines or platform services to provide more better APIs to interact with the live or historical data that is collected via pipeline. Then in the domain of resiliency and fault tolerance, we're currently investigating how to make it more robust and how to make it more resilient against failures, especially, for example, when a whole node goes down. How do we handle that more resilient and more fault tolerant? And lastly, provide better monitoring and statistics of current state of pipeline execution and some other more relevant statistics for the operator of such systems, like processed events or any other errors. So if you want to get involved, we got use Jira for collecting our issues. Start looking at the current SIPs, so the StreamPipes improvement proposals in Confluence, where we discuss more in a brainstorming kind of way what could be a solution for various features that we try to bring to the open source edition. If you're interested, you can also subscribe to the mailing list or our Slack channel and get involved in the discussion or provide us with feedback, what would be valuable and what would be features that we need to put more focus on, and just help us to grow the community, spread the word about the technology. We always welcome, such as today, to have this wonderful opportunity to talk to you guys in Brazil and Latin America. And if you're eager and if you want to contribute, we're also happy or always happy to have contributions, not only for like the backend side of things, but also for UI features or for docs and blog posts, for example. If you want to get up and running, we provide a Docker-based installation setup on our homepage. You are guided through the installation process, and it consists of a Docker Compose file that spins up the various microservices on your local machine within a couple of minutes, depending on your internet connection, for downloading the images first. And you then just basically finish the configuration in the browser. So with that, I'd like to thank you, not only for the opportunity to speak here. Thank you, Edgar. So it was really nice that we got the chance to present StreamPipes to your community, and we're happy to any kinds of questions or feedback on that side. And yeah, here we provide any other details, how you can reach us on various channels. And yeah, if you liked what you saw, and you can check it out with a Docker Compose Docker-based installation. We're also happy if you leave us a star on GitHub. And with that, I think switch over to the Q&A part.
Also, thanks a lot from my side, and now we're happy to answer your questions.
Okay, we have a few minutes. Maybe you have a chance for throw some questions. Let me ask Cristiano. Cristiano, pode pôr... Eu vi duas perguntas ali que a gente não... Algumas eu respondi ali durante o chat, para não deixar o nosso colega Leandro esperando, mas acho que eu vi duas perguntas de outras pessoas aqui. Uma que falava sobre... tá aqui mais para cima. Consegue colocar para a gente, e Cristiano? Já está até em inglês. Well, in the meantime, Patrick and Philip, that was a very, very nice presentation. Very, we love when we know that to do live demonstrations is a very tough, task, because we always are looking for that everything works, and hopefully everything works there. And we saw a lot of interesting questions, which for me, it's a sign that people, they understood, or at least they got intrigued by what the StreamPipes capabilities and what it can help in order to facilitate, the things for, stream processing, IoT, and all this industry 4.0 that we have in the world. So there is this question that was raised by one of the attendees. Let me read. So, how to avoid trade-offs between simplicity, productivity offered by StreamPipes, and yet be able to support a large data volume. So, I don't know if you guys understood okay, let's say in this way. Okay, this is easy, this is connectable, a lot of fancy UI, but is that possible even with this, let's say, easy, tooling to solve very complex stream processing use cases? If this is the goal from this question.
I think it's a very good question, because we try to focus on the user so that the users can use the simplest user interface, graphical user interface, to build their execution pipelines. In the background, we rely on other technologies as Apache Kafka or Apache Flink. So for smaller setups, we usually use our Java or CD wrapper, but you can also rely on those big data technologies. But if you want to put them into production, you have to configure them in the background as an administrator. So you have to, if you want to have a bigger system, you have to configure those individual systems on the setup time to get also the scaling factor out of it. Maybe Patrick, you...
Nice.
Yeah.
Any contribution, Patrick?
Definitely. So basically, it was a really good question, because it's always that kind of trade-off that you're facing from having super simplistic kind of interaction with a user that we think of as a non-technical person, and on the other side, still having some scalability requirements that you need to address here. And we're handling that maybe a little different than other frameworks here and there. So for example, we're not like Beam, for example. So we're not directly breaking down like so-called pipelines into or code generations that are then deployed into Flink, for example. So someone like the actual developer of an algorithm has to implement that logic. So it's not really or might not be the end user who's using it. So what we are doing is to provide this kind of management abstraction around, for having him more or less or the developer more or less having an easy way to interact with the system. Therefore, building or relying on building, for example, a Flink job that can be scalable when configured correctly, like the cluster that is executing the job, but then someone else can then still use graphical interaction to connect to these various data sources and then deploy that job into the Flink cluster. So it's always that kind of trade-off. I think we're,
Well, no, that's great. That's great. No, for me, it makes a lot of sense. You know, like, again, we know that there is no, silver bullet solution for anything, right? But the job you guys are doing, it's so far is incredible because, again, one of the ways I've been explaining StreamPipes to the people, it's that you guys are democratizing, a kind of a technology that's not too accessible to most of the people, right? So this is a very, very good job that you guys are doing at the moment. There is I think we have just a time for the last question before we finish. Cristiano, pode pôr a última pergunta aí para a gente encerrar? Cristiano is going to be presenting the last question. He presented, I guess. Cristiano, tá acordado? Cristiano caiu. Let me get the question from. Okay, maybe this is a very quick answer. When StreamPipes should be promoted to a top-level project in Apache Foundation? I don't know the process. I don't know how it works. To be honest, I don't know even the difference about it. Incubating looks like a project that is in early stage, but looks like you guys are evolving like pretty fast, right? So I don't know if you guys could answer that.
You want to take that?
So also a very good question. So we came to the Apache Foundation, we started to transform the project in the beginning of this year, and we adapted all of our processes, moved the code to the Apache repositories, and we already did our first 2 Apache releases. And currently we are focusing on community building. So we are trying to attend as much meetups as possible. So if you have any feedback or contributions, please let us know, contact us on Slack or via email. So that's the current stage, is that we are further developing the system, preparing our next release, and also growing the community. And once we are ready or feel ready to graduate, we will start that process. So we hope to start early next year, but it depends on a couple of factors.
Okay.
So the most important part is to get more people involved into the system, get feedback, improve it, and spread the word.
Okay, we hope to contribute from now on, right? Maybe just the last one, right? Let me translate this. Do you guys could maybe use case about how big the data volume you guys already processed with the StreamPipes? Any idea or anything you guys could share?
So I can start with a robot use case. So we had an instance installed collecting data from UR. So it's a universal robot. It's just like a small scale ABB KUKA robot that are quite popular in the domain of manufacturing. They have this flexibility and these kinds of data streams are really high frequent. So I think it was 900 hertz. Was it like this, Philip? 900 hertz of input stream coming from only one adapter, and that ran quite smoothly. So I mean, it's always depends in these kinds of scenario whether you really need that much of information coming from the raw sensor. So therefore, I mean, we can handle it at that point. But the question then is more geared towards what you really want to achieve with that input data stream. So, and therefore, currently, we're also working on like putting more like transformation rules into the adapters directly. So you can also already reduce event rates here quite early, so that we're not overloading the system. But yeah, so this is the scale that we had from the frequency side. Maybe you have some figures for the volume side, Philip?
Yeah, also I just wanted to say it highly depends on the kind of data that you're processing. So since we are quite flexible, so you can have like images which are big events, or you can have like just GPS events which are very small. And then it also depends on the algorithms that you're using, if you're using stateless algorithms or also stateful algorithms. So, but yeah, as Patrick mentioned, that those are, and also if you're using just one computer or multiple, like a cluster to process the data. So there are a lot of variables in like the processing scenario, and also what Patrick said, like we had those robots connected with those couple of hundreds of hertz, but usually you reduce those event rate when you process data directly on the ingestion.
Okay, no, that's great. That's great, guys. Oh, okay. So we are a little ahead of the planned time. So Patrick and Philip would like to thank you guys so much for the opportunity to share all this knowledge and information about StreamPipes with us, right? And then we'll be looking forward to try to do this more often, maybe addressing some particular use case in the industry use case in order to make this even more streamlined to the people. Okay, so I'd like to thank you guys so much. Now switch to Portuguese. I'd like you guys to give you your last, you know, like words in order to finish, wrap up this live. Okay.
Yes, thanks a lot for having us. Was a pleasure to show you the system. And if you have any questions, just contact us.
Yeah, and thanks from my side as well. So really interesting questions, some super feedback on that side, and thanks for the opportunity to sharing or bringing StreamPipes to your world. And yeah, if you have any question, just contact us in any way.
Okay, I would say something that I learned in the southern in Brazil. There's a very large German community in the southern here. So Duncan Shy, I don't know if that's correct, but I try my best, right? And now switch para o português. Pessoal, muito obrigado pela presença de todos, tá ok? A gente vai ficando por aqui e a gente se vê na próxima. Um grande abraço e até lá.